Okay, let us discuss problem number 1.6C1. So what this problem says, so let me first make the diagram for this problem. So we have a diagram, figure 1.13. So we have an inclined plane and there is a object of mass m and this angle is alpha. This object is basically pulled up and this angle is beta. So question says, so mass of this object is m. So let us read the question. So a bar of mass m is pulled by means of a thread up to the inclined plane, forming an angle alpha with the horizontal. The coefficient of friction is k. So here we have coefficient of friction k. Find the angle beta which the thread forms with the inclined plane for the tension in the thread to be minimum. So we have to find beta so that tension is minimum. Now you see, in this question we have to find minimum tension and thread is just pulling this object m. So this just pulls. This means acceleration of this block is almost zero. So this is just a tendency to go up. So acceleration of this block is zero. So I can say acceleration of this block is zero. So this object has a tendency to go up. Now let us say the tension in this thread is T. So I can say tension in this thread by which we are pulling. So this is the T. Now I can apply the forces. So if you see on this subject, this side you will have a component of tension that is T sin beta. This side you will have T cos beta. So let us say we have this side force that is T cos beta. This side you will have T sin beta. Now this side also there will be a normal reaction that will act on this mass. So normal reaction is also acting up. This object has a tendency to go up. So friction force will act in the downward direction. You are getting? So friction force, the value will be k times n, and another force that is mg sin alpha will act in the downward direction. So in the downward direction two forces will be act. So let me show the same diagram again. So I can show something like this. This side the force is acting T cos beta. This side force that is acting is normal reaction as well as T sin beta, and this side we will have a force that is component of mg, that is mg cos alpha, because this angle is alpha. So this angle is alpha that is given in the problem. This side force that will act is mg sin alpha. One another force that is friction will act downward because this is a tendency to go up. So friction will act in the downward direction, that is mu times n. Mu is equal to k. So friction force will be k times n. Now I can write equation in this direction. So n plus T sin beta, that is perpendicular to the plane, is equals to mg cos alpha. So from here I can write n, this is equals to mg cos alpha minus T sin beta. So this is equation number 1. Now I can write equation in the parallel direction, inclined plane and the parallel to the inclined plane. In this direction basically acceleration is 0, just this block has a tendency to go up. So acceleration is 0, so I can write total force in the upward direction, that is T cos beta. This is equals to total force in the downward direction, that is Kn plus mg sin alpha. Now I can write this is t cos beta. This is equals to kn, and n we can put from the top. So n is mg cos alpha minus t sin beta, this plus mg sin alpha. Are you getting? Now I can solve for t. So let us say this t goes this side, so I will have t common. So we will have cos beta plus k sin beta is equals to k mg cos alpha plus k mg sin, so mg sin alpha. So I will have k mg cos alpha plus mg sin alpha. From here I can say, so t is basically equals to, if I take mg common, so this will be k cos alpha plus sin alpha divided by cos beta plus k sin beta. Now you see this t is a function of beta. So this is a function of beta, so there is a beta. Now if I vary this beta, tension will change. So I need tension to be minimum. Are you getting? So if I need tension to be minimum, I have to have this function to be maximum. So what I want is, I want to maximize, basically I want to maximize this function, that is cos beta plus k sin beta. So if I want to maximize this function, I have to differentiate this and put it equals to 0. So if I differentiate this, so this will becomes minus sin beta plus k cos beta. This is equals to 0. So from here we will have tan beta is equals to k. So this is a condition for maximum of this function, and is the same condition for minimum of tension, because if this is maximum, this will be the minimum. So this is a condition for minimum of tension. So tan beta is equals to k is the condition for minimum of tension. So angle is given by tan beta is equals to k. What is the value of tension I can find? So tension is given by this equation, mg k cos alpha plus sin alpha divided by cos beta plus k sin beta. Now tan beta is k. So if tan beta is k, I can find what is the cos beta, what is the sin beta. So tan beta is k, this means this is k by 1. This angle is beta, this is under root 1 plus k square. So if I plug these values, so I will have t is equals to mg k cos alpha plus sin alpha, and this divided by cos beta. Cos beta is 1 by this, so 1 by root over 1 plus k square plus k sin beta. Sin beta is k by this, so this becomes k into k square root over 1 plus k square. If I further write, we will have mg k cos alpha plus sin alpha, this divided by k square plus 1 root over k square plus 1, so simply this is k square plus 1. So this is the minimum tension that you will have in this case, and minimum tension is given by angle beta, and beta is given by tan beta is equals to k, or you can say beta is basically tan inverse k. So beta is given by tan inverse k, where k is the friction coefficient, and the minimum tension is given by this function. This is a pretty easy problem. I think all of you have done this one. Okay, let us discuss the next problem. I think all of you have done this problem.